Good morning. Now, uh, this is our second class on the module oscillations. Now, here we are going to derive an expression for time period and frequency. Okay, so let us begin. Uh, in the earlier classes, we have derived the differential equation for simple harmonic motion, right? What was it? D square x by dt square plus omega square x equal to 0, and its solution was of the form x equal to a sine omega t plus 5. Okay, that is nothing but displacement of the particle executing simple harmonic motion. So that is again written here. Displacement of particle executing simple harmonic motion is given by this one, x equal to a sine omega t plus 5. Now what we are going to do is then x is the displacement, a is the maximum displacement, that is the amplitude, omega t, frequency omega is 2 pi by t, then phi is the phase angle. Okay, now suppose that the time factor is incremented by 2 pi by omega, then this above equation can be written as x equal to a sine omega is kept as such. Since time is incremented by t 2 pi by omega, it will become t plus 2 pi by omega. That is, in for this time t here, you have to include 2 pi by omega because it is incremented by a factor 2 pi by omega. Then plus 5 it is kept as such. Okay, now a sine is kept as such, omega t, this omega and omega get cancelled, so it is 2 pi, then what is left is plus 5, that is again equal to a sine omega t plus 5, that is this one is taken as 5. Okay, now this means a particle or the displacement of a particle executing simple harmonic motion is the same when t is incremented by 2 pi by omega. That is, the displacement of the particle when time was t will be the same as the displacement of the particle when time is increased by 2 pi by omega, or we can say that the particle will repeat its displacement after every 2 pi by omega seconds. That is, after every 2 pi by omega seconds, the particle will continue to execute, or it will continue to repeat its displacement. Okay, therefore time period of a simple harmonic oscillator will be t equal to 2 pi by omega. So we got the expression for time period t equal to 2 pi by omega. Now in place of this omega, omega is angular frequency, you just substitute this value root k by m in this equation. So what will be t look like? T will be 2 pi by root of k by m, which is nothing. T is equal to 2 pi root of m by k. Equation 7. Okay, now our aim is to obtain another expression for time period, another form. That is, now from the expression for acceleration of a particle executing simple harmonic equation, that is from equation 5 that we have already discussed in the last class, equation 5, we can obtain another expression for time period. How? That is, here we have already obtained an expression t equal to 2 pi by omega, that is one expression for time period. Now we are going to derive one more expression for time period. So for that we have to start with angular frequency as root of a by x. A is acceleration, x is displacement, omega is angular frequency, or t equal to 2 pi by omega, that we have just wrote. Now t equal to 2 pi by omega. Now in place of this omega, you can use this value, that is root of a by x. Then t will reduce to t equal to 2 pi root of x by a. That can again be rewritten as t equal to 2 pi root of 1 by a by x. Root of 1 by a by x is the same as root x by a, right? So we got an expression or another expression for time period, which is this one, t equal to 2 pi root of 1 by acceleration per unit displacement, that is a by x, acceleration per unit displacement. A is acceleration, x is displacement. Okay, so you have got two expressions for time period, which are they? T equal to 2 pi by omega and t equal to 2 pi root of 1 by acceleration per unit displacement. Study these two equations because you will be asked to solve problems. Now, next we are going to derive an expression for frequency. What is frequency? Number of oscillations made by the particle per second. Now frequency is a reciprocal of time period. Okay, so f is equal to 1 by t, which is equal to 1 by 2 pi root a by x. That is again equal to 1 by 2 pi root of acceleration per unit displacement. So that is the expression for frequency. 1 by 2 pi into root of acceleration per unit displacement. Study this formula also. Unit of frequency is per second or cycles per second or hertz. Now the relation between angular frequency and frequency is omega equal to 2 pi f, that you know. Now what is angular frequency definition? It is the angle described by a particle per second and it is expressed in radians per second. Okay. Next one, phase and initial phase. So from this session up to this much, which are you have to study two expressions for the time period, expression for frequency, etc. And these are all its derivation, how to derive the expression for time period and how to derive the expression for frequency. Okay, now another one question is define angular frequency. Now let us see what is phase and initial phase. Phase of a particle executing simple harmonic motion at a particular instant of time is defined as the state or condition with respect to its position and direction of motion at that instant. That is, phase of a particle denotes its position and direction of motion at a particular instant of time. That is, if we say that phase of a particle is this much, then that actually means that the condition or the state of the particle in terms of its position and direction at that particular instant of time. That is the definition. Now it can be expressed as an angle or as a fraction of total angle 2 pi described in a time period. Or another way to express it is in terms of time as a fraction of time period t. Okay, so these are the two ways in which a phase is represented. Now let us see what is initial phase. See, this is the expression for displacement that we have already seen, x equal to a sin omega t plus phi. Here, this omega t plus phi is the called phase of vibration and phi is called the initial phase or epoch. And it is a constant and it does not have anything to do with the vibration of particle. But this phase or the information on phase help us to find out how far from the equilibrium position of the system was at time t equal to 0. That is, initial phase phi actually tells us about the state of the system from the equilibrium system, the state of the system from equilibrium position at time t equal to 0. That is, how far the system is from the equilibrium position at time t equal to 0. That is what we get from phase. How far the system is from equilibrium position at a time t equal to 0. That information is obtained from initial phase or epoch phi. Okay. So here you get two questions. Define phase and how is it expressed? That is written in this paragraph. Then what is initial phase and what information do you get from it? Okay. Now this is some graphical representation, that is displacement versus time, then velocity versus time and acceleration versus time. This one they will specify the question, that is explain and draw the diagram for acceleration versus time, or they will ask explain and draw the curve for displacement versus time, like that. Sometimes they will ask all the three. Okay, So here let us start with displacement versus time curve. As usual, displacement of the particle is given by x equal to a sin omega t. Actually there is plus phi, right? Here we are assuming phi equal to 0. So the expression for displacement reduces to x equal to a sin omega t. Now a sin is kept as such, omega is 2 pi by t and small t is kept as such. Now our aim is to find the value of x for different values of small t. Okay, and once you get that point, using that point you can draw the graph. Now first value that you put for t is t0, that is when t equal to 0, this is actually x. Okay, x equal to a sin 2 pi by t small t. When small t equal to 0, what is your x? It is 0. Okay, because sine 0 is 0. When you put t equal to 0 here, this term will become 0. Sine 0 is 0. 0 into a is 0. So x is 0. Now put the next value for t in this equation. That is t equal to t by 2. Put this value of small t by 2 in this expression. Then what will be the value of x? It will be 0. So just substitute and look. Okay. Now when t is equal to t and t will get cancelled. Again the value of x will be 0. Now put t equal to t by 4. Then you will get the value of plus a. When t equal to 3t by 4, the value of x will be minus a. So for this is your x. For the small value of t, you are substituting values 0, t by 2, t by 4, 3t by 4, and for each of these t values, you are calculating the value of x. Now you will get all these values of x. Now based on this x and t, you are going to plot a figure. See, this will be the figure displacement versus time curve. 0, t by 4, t by 2, 3t by 4, t. This actually completes one cycle. Similarly, velocity time curve. Velocity, you know, it is dx by dt. D by dt is kept as such. What is your x? A sin omega t. Now, this a is taken outside. A. Then what is a derivative of sin omega t? Omega cos omega t, right? This one. A omega is kept as such, cos is kept as such. In place of omega, you substitute 2 pi by t. Small t is kept as such. Now, what is the next step? As before, for each value of t, you calculate the value of x. That is starting from t equal to 0, t by 2, t by 4, 3t by 4. You calculate the velocity of v. LHS is v here. So, for each of this value of small t, you are calculating the value of v. And finally, you will get a curve like this. This is the shape. Finally, acceleration versus time. As usual, acceleration is nothing but d square x by dt square, which is minus a omega square sin omega t, which we have already discussed in the last class. Here also, you substitute different values for the small t, that is 0, t by 2, t by 4, 3t by 4, and calculate the value of this alpha acceleration. So based on those values, you will draw a curve, and the shape of the curve is like this. Okay. So sometimes they will specifically ask you to explain and draw the curve, okay, of any one, that is displacement versus time, or acceleration versus time, or velocity versus time, etc. Sometimes they will ask all the three. From here, the possible question is, what is phase? How is it described? From second paragraph, what is initial phase? What is its significance? That is, it helps us to know how far from the equilibrium position the system is at time t equal to 0. Here you have derived the expressions for time period and frequency, and remember the formula for calculating time period and frequency. T equal to 2 pi by omega and t equal to 2 pi root of 1 by acceleration per unit displacement. These are the two expressions for time period, and for frequency it is 1 by 2 pi root of acceleration per unit displacement. Okay, so these are the important questions from today's session. Thank you.